Hello my friends. A clickbait thumbnail with Minecraft in the background to attract viewers and for a new channel. I probably won't do that anymore. Oh, you need a result with a bright picture. Here's a picture. And the result, well, I think this can be considered a result. I haven't had progress tracking yet, and it's quite far from the program's final answer. More precisely, I don't know when it will decide to answer. In theory, it should develop everything the user asks for, or at least something the user asks for. But I didn't have enough money and time to pay for an API or wait for inference to happen on my computer. What progress, what program? I'll tell you everything in order, but let's first install Milana and give it a test. After standard installation, choose the language and proceed to set up AI connection. You need to provide your token or running local server. If there is a token limit parameter, it means the provider can't determine it. Find and enter it manually. In Llama, this parameter is ignored. If you use a cloud API, it's advisable to download an Llama embedding model. It works fine on weak PCs, even on a CPU, and it's free. Llama uses embeddings a lot, so you'll save a lot. Switch the provider to use the local server. Test the connection, save the settings, create a chat, check out the tabs. You can set a limit on hierarchy steps. Default is 0, meaning infinity, number of attempts. Default is 4, but they don't work. More of that later. Leave the advanced chat mode enabled unless you think it corrupts the engine's dialog memory. When enabled, it uses a vector database, implemented similar to rec, and when disabled, the dialog is simply compressed when full. The generation cleaning switch removes text after found agent roles written on a new line, or text after second found agent comment. Weak models can get confused and start generating the entire dialog instead of just their own message. Otherwise, it's better not to enable it. In the Models tab, which are tools for the AI agent, there are several default models, the most useful of which is probably internet search, must be. You can also write your own model following the instructions on GitHub. You can connect as many models as you want. Milana automatically selects the necessary ones when creating an agent, depending on the task. Finally, you create a chat, write the task, and forget about the program for an indefinite amount of time, only to later find out the interface got stuck, restart the inference, chat, and with some probability get a safe error. I choose Alzheimer's because there were scandals related to it, and the complexity of research itself was high. Maybe Milana can come up with something. Special thanks to GPT for all. Llama hadn't added Vulkan yet when I started my tests. And currently Llama on Vulkan and its beta version that after a few requests messed it up that data storage and VRAM and wet rest for 5 minutes. GPT for all of course also crashed for me, but very rarely, and I used a script that automatically reloaded GPT for all while the program waited. Even if you use CUDA, it's better to use specifically the combination of GPT for all on GPU for inference and Llama on CPU for embeddings, because constantly loading and unloading models takes time, and models loaded into VRAM by different programs simultaneously cause errors. And also, right before the demonstration, GPT for all suddenly stopped working for me. Thankfully, rolling back the Mesa drivers and Vulkan libraries to November fixed everything. I really hope Nomic doesn't abandon GPT for all, because GPT for all stops working with the newest models and drivers, which makes a very convenient tool for me and introduced Vulkan earlier than Llama. Let's see what happened. So the program called a web search command, the search model found an Italian casino, and that's it. It only made the call once. I think it's time to attract investments. To test on something like GPT-5 mini on better, I need to get a job, well, you know. Alright, later someday there will be a video or stream where I'll connect paid APIs to watch it work in real time after gathering more money. And I still don't know how to track work progress. It could be tracked by setting not only a hierarchy limit, but also possibilities to limit the number of executor switches, cause the new hierarchy levels by one executor, a limit on the number of messages before an answer critical limits. And now the story itself. Once, in 2023, I was chatting with GPT 3.5, asking about some topic I didn't understand, and it made a learning plan. And I had a percentage point of the plan. Of course, models have become smarter now, but that's when the idea of making it talk to itself came about. It's capable, but it does everything in very small steps. Making a plan, outlining a small task, executing it, and that's done with 3 requests. My first prototype didn't have a GUI. All it had was a dialogue between 2 entities based on Mistral. I tasked them with developing a plan to build a city in Antarctica. They almost instantly made a 5-point plan and then spent a long time saying goodbye until I manually stopped the program. Trying to fix this, I added a Gigo function from the acronym garbage in, garbage out. It's supposed to outline the task. For example, when I'm waiting for a plan to build a city in Antarctica, I expect a step-by-step instruction, who to call, what to discuss, what construction materials to order, and then make an execution plan based on the outlined task. Then I started tuning the entities into full-fledged agents. Lacking knowledge about agent work, I went to study the LangChain framework. This framework is developed with the goal of maximum acceleration and simplification of deploying AI agents. But after working with it for a while, I don't recommend it even to beginners. Often in updates, they significantly change the syntax and logic. The idea of click deployment is not universal. There are several types of dialog memory, but it might turn out they don't suit you. They are too general, and there's no flexibility in saving messages, editing, and so on. A simple agent constructor exists, but it still doesn't work in a significant number of cases because the prompts are in English, and if you don't speak English and your LLM doesn't require a clear plan to run, it won't be able to call a tool. In general, if your LLM doesn't require a clear plan, it will have a very hard time calling a tool. It will make mistakes, and LangChain will ignore its mistakes. Your own functions have to be adapted to LangChain structure. LangChain allows changing things, but still within the LangChain structure, which is as fast as writing your own memory and agent, but less flexible and more complex. You have to learn how LangChain works. So I made my own memory and agent, adding a localization and later adding flip to react to commands written with errors. I realized that the execution plan might not be detailed enough. For example, the point deliver construction materials to Antarctica can be divided into subpoints like building a road, calculating cost, and so on. This turned into the idea of creating a hierarchy. Another brilliant idea was to pick all everything from others, which let them now brought to a working state and thus disabled
10,000?
Monkey's method. But from it remained saving the dialog to a vector database, very useful, but more on that later.
10,000!
Monkeys. If you give monkeys a type of writer, one of them will randomly write the novel War and Peace. Learning that you could theoretically save time on the tokenization and detokenization, I started moving all text to a separate file, systex.py. This was a foolish idea. Almost no services return tokens, and for them I had to detokenize the request and tokenize the response, which nullified the speed gain. And tokenization variables depended on the text, the program stopped recognizing comments. Later I started using system text.py for localization. I worked on the same system. Of all the options, only the replay system was suitable, where model generations, database query results, and other critical events are cached. Upon restart, the program takes information from the cache. This works. In the first release I couldn't get it to work, because access the database gets information from the cache, which might no longer in the database, or we get from the cache a model generation that contains a command to create a new dialog once the flower and the program changes some variable related to the new dialog. Otherwise, we would have to track global and local namespaces, and account for variables to restore their values. Replay was the simplest solution from the perspective of embedding into the code. Almost a year and a half has passed. I decided to bring Milana and minimally working state to publish it at some point, and I released it in August 2025. Calling that release working is difficult, but I felt better. I have several projects I never finished. Both the first and second release I finished in a hurry, constantly resulting to using AI for coding. So now you can see the code looks messy and there are bugs. And there is even a dictionary where the key equals the value, precisely due to hastily removing token walk. First I needed to finish the program for users, because the first release could only be called working with a strange. After the first release, I almost immediately started working on the second, fixing critical bugs and adding features. Wanted to turn the program into an Excel file. I wrote a post that said AI helped scientists in research and did something autonomously. There was a diagram where besides agents there was a critic model, and I myself noticed that the program gives an answer prematurely. I made a simple function which I called critic. When it's not satisfied with the result more than 3 times, it doesn't send it for revision but passes it to the user or one hierarchy step up. I substantially solved the problem with the chat template. When a model without a template would start writing multiple messages not from its own name. Showed once to feed them into about 500 tokens and it was changed. The answer cleaning function is left optionally just in case I had to solve this problem to a direct or rather dialog memory based on extracting vectorized messages. Now it works, at least in most cases. And I added mandatory gzip9 compression to the save system, because every critical action gets there constantly. It has to weigh a lot. At the same time, compression and decompression don't take much time. In the future I might take it optional but enabled by default and experiment with compression everything I can reach. But others that will clearly take time, so I also make it optional. And I got the idea to prune part of the cache between one very critical point and another very critical point. For example, if agents are communicating for a while, no new dialog or executor is created, or a dialog is complete, upon reaching a critical point this can be pruned, but only upon reaching. Sometimes throughout the development I was frightened by news like the appearance of reasoning mode, which can solve almost everything, or GPT-5 replacing humans, but recently I was made anxious by the news that Google prevented a model that with high accuracy select system architecture for a task. I spent 2 years on the hierarchical architecture, and that for coding a flat matrix architecture is better, while hierarchical is not due to high data loss between cells and hierarchy steps, and the news that Google presented Alpha Evolve. Let me just quote the post. A document on how to build reliable production systems based on autonomous agents today. Google breaks agents down into 3 key components. First, reasoning model. Second, tools, APIs, databases, browsers, other agents. Third, orchestrator, memory, workflow, error handling. Also introduced is the 5-level classifications of agent systems, from chatbot to self-evolving system. Level 1, reaction to input without memory. Level 2, goal-based planning. Level 3, multi-agent system with delegation. I guess I'm on level 3. Level 4, the agent itself creates new tools or sub-agents when it understands it lacking something. Google gives the example of Alpha Evolve, a reference architecture for adaptive agents, which evolves through RL, HF, and dynamic prompt optimization. I remembered that in an attempt to implement
Just a little bit.
Mannequin's method, I added saving the dialog to embeddings, which somewhat fixes the data loss problem. However, making a dynamic structure seems less achievable for me than after creating necessary tools. For auto-creating tools, I could harness Milana itself, but I also have to think about modernizing the structure. And also in some places, I don't like the current implementation. Reg shouldn't be just any, but perfect for working with small models. It should be the best. In the future, the project has a lot of interesting things, but first, refactoring, debugging maybe, and optimization. Yes, optimization, in Python. What I want to do? Improve replay, rec, critic, gigo, finally normal file work, others are almost known now, and I need to read my endless list of notes on Telegram, with all the other ideas. Overall, I'm trying to make a system like a kindergarten for LLMs. To offload the LLM, also make the LLM think, makes them improvise, which is even harder, and also recognize deception during search. This is a very important task because the system can on search results, and the internet, well, pricing Google search was high. How to clean your ears properly? I cleaned my ears with cotton swabs and then found out that for 90 years, every week or two, I risked damaging something. The AI somehow confused cleaning ears with stealth murders with a nail in the Russo-Caucasian War. It recommended cleaning my ears with my pinky after washing, but my pinky wouldn't fit and headphones were still yellow. I went to ask my friends, how do they clean their ears? The first cleaned like me, with swabs, and the second put hydrogen peroxide into his ear every month and a half. If the first hadn't answered, I would have gone crazy. This happened because the internet is a dump. Anyone can make a medical website, copy crap from another medical website, and so on. Of course, geek information was affected less, because there you'll get tomatoes thrown at you, or at least you'll notice you've been lied to when you break the operating system, for example. But sometimes Perplexity still recommends systemd as a good system. Search AIs just read internet pages. That is the problem. Start and end of the video. I will be glad for your ideas, and ideas on implementing what I want to implement. And I will be immensely grateful if you fix this, or anything else if you don't like.